Okay, so if you have not, I would like you to please just tag your notes to say that this is dealing with absolute value equations. We've obviously looked at solving equations for about a week. Now the idea of an absolute value. Do you guys know anything about absolute value? Most people try to give me a hand signal. Yep. Right. Right. Okay. When it's in these bars, right? Say that again.
Like when it's in the absolute value thingies and it's a negative, it's actually positive.
Okay. So somehow it takes my answer from being negative and turns it into a positive. Okay. Anything else you guys know off the top of your head? We know it involves these vertical bars, and we know that for some reason it makes it positive. Faith?
Yep.
No?
I was gonna say it makes it positive.
Okay. Yeah, and
I didn't listen that well.
that's fine. I think that's kind of the thought process from a lot of us, at least, like somehow it always makes my answer become positive, and so we'll get into that here in a minute. But as we kind of look at what we're going after today, I am going to ask you to just solve one question from last week. There actually will be two choices, so you can choose either one. We'll start with an expression, meaning no equals, and then we'll get into the idea of what does it look like in an equation form. And it's a little bit, kind of probably more than what we're thinking. Not hard, but a little bit more than maybe what meets the eye, so to speak. So if you would, I don't care which one of those two you choose, but take a minute, try one of those. Obviously, the one on the left a little bit easier than the one on the right. So if you're struggling with the idea of solving still, if you're not, then don't try the one on the left. You should be distributing and trying the one on the right. Or there you go. You could try both. It shouldn't take you too long if you do the one on the right to make it look like the one on the left. Connor obviously has way too much time as he lines his notebook paper. Yeah, I'm telling you. He buys lined paper and then lines it again. Just think about that thought in your head. You forever just made the YouTube channel, though, with that comment right there. See? So I posted you in there forever, for life.
Can you give me a shout out? My YouTube channel.
I thought I just did.
From a couple years ago. It's Cfield123. Check it out.
Check out Cfield123. There it is. There's the official post. All right. So if you're solving the one on the right, obviously there's the distribution that's to take place. And for a moment, I don't think I'll do anything with the equation on the left-hand side because we should be able to make the one on the right look just like the one on the left by combining these like terms. Okay. At this point, both of these equations look the same in the fact that they have no more like terms on either side. And at this point, you have to make a choice. Make the decision to move the variables to one side and move the constants to the other. Whatever that is going to be. For most of you, it's probably going to be to move the variable to the left. We like to see our variable on the left-hand side a lot of times. So if that's the case, do that. If you don't care, then maybe you move the 4x because that keeps x positive instead of negative. So it should not be a decimal. Oh, yes, I'm sorry. The one on the right. Yeah, sorry. Yeah. Was you about to say? So if we take this one over here, maybe you move the 7, leaving you with negative 3x minus 2 equals negative 7. At that point, you got to move the 2, and you get negative 3x equals negative 5. And then obviously the last step would be to get out and divide the negative 3. And so I would tell you, leave your answer as 5/3. Don't make it 1.6. If you did that, you're not wrong, but it's easier to work with the decimal, or excuse me, with the fraction. So you got the double negative there, so we can take that off. But there you see the 5 and the 3, so just leave it as a 5 and a 3. If you could reduce it, go ahead and reduce it. If it's like a 6 and a 3, obviously it reduces down to a 2, but otherwise, just leave it. Did anybody do the one on the left? Okay. Faith, do you have a question first? What's up? In the answer? Because the 5 was negative and the 3 was negative, so the two negatives cancel each other out. Did you lose one of those along the way, maybe? You're like, no. So, yeah, the two negatives would cancel. Connor, you did the one on the right? Or the left? I'll learn how to read. What did you get for an answer to that? Y equals 4. So if you move I would assume, probably move the 5, y. So that would leave us with 3y plus 3 is equal to 15, and then get rid of the 3. So we get 3y equals 12, and then we would divide by 3. So we get y is 4. Okay, so we'll still need that idea today, solving absolute value equations. However, they're going to look just a little bit different. They're going to involve the vertical bars, and they're going to involve this idea of something being positive. So that's what we're going to get into. We're going to look at it two ways. We're going to do it first, evaluating expressions, meaning not an equation. So we're not solving anything, but we're going to have some values for maybe a or b or x or y. We'll have values of some sort, and we'll plug those in, and then we'll get into the idea of solving an equation. So we're going to start here with this one. Okay. As we look at this, though, I want you to think about the following. We're not wrong to say, these vertical bars, and we're not wrong to say that the result there is going to be positive, but truly, absolute value implies how far away from 0 something is. How many units away from 0? Okay, and so if you think about that, you can't really be a negative number of units away. Distance isn't negative. It's directional. You can go forwards, backwards, right, left, but you can't go negative steps. All right. Sometimes you guys would like to rewind something maybe and do it again, but you can't do that. And so the value cannot be negative in this scenario. Correct. Well, so this result inside the absolute value, if we have to substitute in that value of 5 there. So we get 5 minus 7. We will treat those absolute values the exact same way you would treat parentheses. So we'll work inside of them first. Now, look how poorly I wrote my two absolute values, right? The one on the right is more the way it should look. You be careful that you don't turn that into a 15. Okay? So I would really tell you, like, maybe over exaggerate that a little bit, just so you don't do that. Now, if this value inside the absolute value is a -2, we're really saying how many units away from 0 is that? And obviously the answer is 2 units away, which is why it becomes a 2. It's not that it just always makes everything positive, but when you're talking about distance, it can't be negative. Okay, and so we end up with an answer of 17. Now, kind of thinking along that, try this one and see what you come up with. So remember, we're going to work inside of them just like we would work inside of a set of parentheses. James, you just doing this all mentally? You against the pencil? All right. If I just start throwing random numbers at you, will that interfere with what you got going on? Challenge accepted. Han, you got an answer? What do you got? -1. Connor, you don't like that answer? You're confused. Okay. Well, so like I said, let's treat this like a set of parentheses. So let's work inside of those first. Obviously, 2 and -8 would give us -16, and then 4 times 3 would give us a 12. -16 and +12 is a result of what, Faith? -4. So I've yet to apply the absolute value, so it's still there. So -4 minus 5. Okay. Now, the absolute value of -4, or how many units away from 0 is that? And Emily, you would say it is 4. So this -4 turns into a 4, and I've yet to do anything with the -5. So I'm still kind of like following my order of operations. And then 4 minus 5 would leave me an answer of -1. Yes, ma'am. Why do I wait so long to change what? Well, because I haven't gotten a value out of this expression. So if we look at just this part here, I haven't gotten an answer to it until right there. And at that point, I have a value. Now I can determine how far away from 0 it is. But up to that point, I didn't have an answer for that part. So I'll continue to keep it until I get there. Just like a set of parentheses, you wouldn't drop those parentheses in a problem until you had done whatever was there. And once you had completed it, then you could remove them. But we didn't get to that point. Now, I don't know if anybody's thinking this. Wait a minute, you just told me my answer can't be negative, but yet I have an answer that's negative. Anybody thinking that way? Connor? Yeah. I mean, and that's a valid thought. Why? Okay. And so that really only pertains to that part right there. Yeah. And so that -5 after it is completely after the fact. It is not contained within the absolute value, so it doesn't have to hold to that policy, so to speak. Okay. So when you're dealing with expressions, we want to treat those absolute values the exact same way we treat parentheses. We'll work inside of them. Once we finish them, we can remove it, and then we can go from there. All right. Now, if we look at it in terms of an equation, we got to think a little bit differently. Okay, so if you're solving an absolute value equation, there's 2 things you got to consider. What if the expression inside is positive or 0? Either one of those options. Secondly, what if it inside of there is negative? And so we'll look at those 2 scenarios kind of moving forward. Here's something important to remember though. Whatever this absolute value is, whatever it happens to be equal to, so in this case we're calling it B, B has to be greater than or equal to 0. We just said that whatever came out of an absolute value could not be negative, right? So whatever this thing is inside of here, whatever this A is, whatever it's going to be equal to, can't be negative. And that's important to remember. All right, and we'll see what that looks like here in a minute. So we're going to look at a handful of examples. I think you'll get the idea of it pretty quickly. We're going to keep these equations pretty simple today, just so you get the hang of what's going on. I would venture to guess you could just look at that right now and tell me a value of x that makes this work. Like, can you think of a number that you could put in right here for x that would work to make that statement true? Declan? 4, right? I mean, if you put a 4 in there, 2 times 4 is 8, and 8 minus 1 is 7, right? So x here in this situation could be equal to 4. But there's another number that makes this work as well. Now, I'm not a mind reader, but I have a good guess on what you're about to tell me. -4. But if you put -4 in here, what do you get? Because you don't get 7. You actually get -9, right? I mean, 2 times -4 would be -8, minus 1 more would put you at -9. Allison? -3. If you put a -3 in here, that's -6, minus 1 more is -7, but the absolute value of -7 is actually 7. So there are truly 2 answers that make this problem work. Okay? So here's what we're going to kind of do in our notes. Every time we think about an absolute value, we're going to kind of start this way right here. There are actually 2 options that we need to consider. What if it's equal to a positive value? What if it's equal to a negative value? Now, Declan, were you the one that gave me the first answer? Okay. You were trying to satisfy this equation right here to be equal to what? Okay. So in the first option, we were actually trying to make this 2x minus 1 equal to 7. That was our goal, right? And that was the one that we saw first. Allison, you weren't actually trying to make the 2x minus 1 equal to 7. You were trying to make it equal to... No. You told me the answer was going to be -3, right? But what value was the expression actually equal to? It wasn't equal to 7. Charlotte? -7, right? Because 2 times -3 minus 1 more was that -7. You with me? Okay, your eyebrows say otherwise. All right. So over here, we're actually trying to make it equal to -7. So when we're looking at absolute value, we have to think about 2 scenarios. What if this thing is equal to the positive version, and what if it's equal to the negative? Both of these we would solve the same way, right? Move the 1 to the other side, divide by 2. That's how we end up with these 2 results. But the thought process is, in an absolute value scenario, there's not just one option, there actually are 2. Are you with me on that thought? Okay. So, if we look at this one, what's the first thing, besides writing it down, that you probably should do here? I shouldn't even say probably. You got to do this first. Faith, you got an idea? Not yet. There's actually something you got to do before that. This one's a little different than the last one. Just a little bit. No. Allison? You cannot do that. You're going to have to do some with that -2, but you're not going to combine it with what's inside the absolute value because that's kind of on its own. Yeah, you're going to have to move that 2 to join the 6. How are you going to do that? You're going to add it to the other side. Yep. It's on the other side of the equation, so you're going to have to add it over there. That's going to cancel. And we're going to be left with the absolute value of 2x plus 4 is equal to 8. Now, that means that expression right there should go in both of these boxes. What are you going to write over here on the left-hand side? Do you know what it is, Brooke? Well, give me the equation that I'm really looking for. And if you can solve that in your head, that's fine. But tell me what this equation is over here that I'm trying to solve. Do you know what it is? Okay, so there's number 1. And if you can look at that and solve it, by all means, go for it. All right. That's our first option. What's our second option? Alexis? When you say add all of those.
So what I was doing at first is like solve the equation at 8 because that's two. Oh, like it's 2 more than 6, and then just subtract 2 from 6.
Give it to me one more time. I don't think I didn't catch it yet.
Why couldn't you just solve me like? So I was gonna do what we did to get to 8, but then just subtract 2 and get to 6.
I got you. So you're just kind of saying, let me just leave those things, so to speak. Is that what you're saying to me? I mean, you can. I think it would be easiest, especially if as this gets bigger, to think about kind of peeling away everything that's not attached to the absolute value. So, just for example, if there was a value, like let's say there was a 3 outside of there in front, which would say whatever comes out of here, multiply it by 3. I don't know that I'd want to hold all that in my head, thinking about what pieces, parts are attached to it. And if I just kind of stripped it all out of there, I could get it all the way down to what's the expression inside of there and what's it have to be equal to. So if that means moving a 2 and dividing by 3, let's say if there was something out front, so to speak, I think it'll be easier for you in the long run. But I don't think you're wrong. I think you're still going to come up with the same result. If that makes sense. Does anybody know what the expression would be or the equation would be over here, Declan? Sorry, what? The equation over here? What are you thinking about? That's an answer. Okay, that would be the equation over here. 2x plus 4 is equal to negative 8. Now, if you can solve those in your head, okay, that's fine. But we need to get it to a point where we understand what values it is that we're looking for. Yes, ma'am?
So the two sides of this.
Yeah. Because what you're saying here, remember, in an equation, both sides have to be equal to each other, right? And so on the left-hand side, we have this 2x plus 4. And really the question is, what turns this 2x plus 4 into an 8? That's really what we're asking ourselves. And over here, some of you guys, I'm sure, figured out that this answer had to be a 2, right? Because 2 times 2 is 4, and 4 plus 4 gives me 8. But in an absolute value situation, it doesn't necessarily just have to be 8 that makes that true. It could also be negative 8 that makes that true. And so you have to look at it from both of those perspectives. With a typical equation, we only look at whatever it says, but with an absolute value, we actually produce a second option. Now, this one over here, do you have an answer to that one? Hunter, you got an answer to that one? Negative 6, good. If you move the 4, you would get negative 12, and then if you divided that by 2, you would get negative 6. Okay. Now, the last thing, and I didn't do this on the last one, and that's my fault. Oftentimes when you're dealing with absolute values, they ask you to graph your solution. If we look down here, graphing a solution is not really a big deal, especially if you cheat like I did and already had a number line ready to go. Okay. Do you know how to graph a solution on a number line? Yeah, you do. You ever shot a paintball gun? Because that's about as hard as it is to graph this. Yeah, you just plot the number. Yeah. So, like in this scenario, if it was x equals 2, well, there's 2. And the other option was negative 6. Well, there's negative 6. And that's it. That's all you got to do. Okay? So not that it's crazy, but that there are 2 options. Okay. Any questions so far? Yes, ma'am. It is both of them. Yep, because both of those values, and you could come back up here. If you put a 2 in here, that's 4, and 4 plus 4 is 8, and the absolute value of 8 is 8. So that answer works. And if you put a negative 6 in here, that's negative 12, Add 4 more, that's negative 8, but the absolute value of negative 8 is 8, so that answer works. So they both work. Okay? Cody, you under there? Barely see your eyes. There they are. All right. Now, what about this one? What do you think? I would tell you anytime you're dealing with an absolute value equation, I think this thought right here of what you see is probably how you should start. Like, there are going to be 2 options, potentially. This is the easiest problem out there. Oh, I promise. You know how much work it involves? Watch this. That much right there. I'm not going to write anything. I'm not writing anything for this. Well, I guess I could write this if you wanted me to. Why in the world would I say that? Ha! Connor, why would I say that? Excuse me? P's equal to nothing. What you mean? Allison?
I was trying to solve it.
Yeah?
And then I was like, oh wait, absolute value makes everything possible.
Yeah. Yeah, if the absolute value is going to force your result to be positive, how in the creation could it ever equal something that's negative? That wouldn't be possible, right? So, what's that? Well, okay, pick some value. You probably were trying to like put a number in here to make this work, right? Like maybe you were trying to say negative 11, right? Because negative 11 plus 6 is negative 5. But then you have to apply the absolute value. What's the absolute value of negative 5? 5. Well, that ain't equal to negative 5. So in this scenario, when your absolute value is equal to a negative, you actually can't do anything. Yeah, well, not really, but I guess kind of. If you think about this all the way back here, remember we said whatever that result was had to be something that was greater than or equal to 0 because there's no way that it could come out to be negative, right? So as you're looking at problems or you're looking at your homework tonight, this would be like your ideal situation, right? Because what do you got to do? Nothing, right? You can't do it, okay? So when it's equal to a positive, it's going to guarantee me how many solutions? 2 solutions. If it's equal to a negative, it's going to be how many solutions? No solutions. So I guess obviously then the last scenario is, well, what if it's equal to 0? Faith? Okay. Oh, I don't even know what you said, to be honest with you. Now hold on here. You're going to mumble through a word and then try to tell me to understand. Declan? Undefinable? I don't know that that's a word either. Well, hold on. Hold on here. Well, listen, here's the thing. We're trying to define or to find a word that really does not apply in this scenario. If you're solving this, remember, the statement would be looking at that expression right there and figuring out when it's equal to the positive and negative version. There is no such thing as negative 0. Yes, ma'am? Correct. So when I write my first scenario here, like try to figure out when this thing is equal to 0, I would not come over here and write 2p. Okay, sorry. I wouldn't write 2p plus 6 is equal to negative 0. That's not real. This answer over here isn't possible. So there's only one solution. Okay? Because you can't have a positive or negative version of nothing. There's only one version of nothing. Okay? Well, so in this situation, the answer is going to be whatever that one solution is. So in this case, take, I don't know, less than 10 seconds probably. Can you tell me what that answer would be? Negative 3. So here, if I was thinking about this one, there's only one solution to that one at negative 3. All right. Now we have one thing left to look at, but before we do that, I want you to put this in your notes. Solutions to absolute value equations. How many scenarios are there? How many scenarios are there to an absolute value equation? There's 3. Option number 1, my solution is positive. How many answers will I have? Brooke, how many? Good. If my solution is positive, there's going to be 2 answers. I don't necessarily know what they are yet. I just know there'll be 2. Option number 2, if my solution is 0, how many answers are there? There's going to be, Dakota, how many answers will there be? 1. There's going to be 1 answer. And my third option would be that if the solution is negative, there's going to be no answers, no solution. So no answer. Okay? So as you're looking at your homework tonight, obviously you're hoping for what? You're hoping for, sure, you're hoping for this, right? So as you look at an equation, we're not done, so don't put your notebook away. We hope that it's equal to a negative, because that means we don't have any work to do. I guess then we next would hope that it's equal to 0, because that's only going to be one solution. If we see that it's equal to some positive value, that's a guarantee that there are 2 solutions out there that I need to find. All right? Now, here's the last thing we're going to look at, and then we're done. What if I give it to you in reverse, and I tell you, hey, here are 2 answers. My question to you is, what's the equation? You already know what it is? Well, we know that it's equal to a positive. I agree with you there. My question to you, though, is what's the actual equation? Or what's a potential for this equation? Yes, sir? Absolutely. Absolutely. So we're going to make one up that works, something that satisfies this scenario. But we know this much. Faith said it's got to be equal to a positive number. Agree? Here's all you got to be able to do. Can you tell me where the halfway point is between those 2? If you can tell me the halfway point, that's all we need in order to solve this. Where is it, Faith? It's at 1. So this spot right there is halfway, right? Because it's how many units in each direction? 5. It's 5 units to the right to get over there. It's 5 units to get that way. It's also 5 units. With this information, with that value right there, the fact that the middle is at 1, and that these 2 units are really 5 units to the right and 5 units to the left, that's all we need. Okay? Do you get it? What's the equation? Cody or Connor, you think you know what it is?
I know the idea of it, but it takes a minute to solve it.
Okay.
I get it what the negative 5 and positive 5 is going to do to me.
Yeah. That's how we're kind of getting 2 solutions, because we have to go 5 units right and 5 units left. The equation is, what do you think? It's not going to have a 4 in it. I'm telling you right now, it's going to have these two numbers. It's going to have a 5 and it's going to have a 1 in it. It's going to look like this. X minus 1 is equal to 5. Okay. Watch. Stay with me. So we're going to do it over here. Well, we'll do it over here. So X minus 1 is equal to 5. Okay. Because that was an extremely large 1 that I made there. Because this is equal to a positive value, right? You have to set it equal to two things. X minus 1 being equal to 5 and X minus 1 being equal to negative 5, right? I mean, that's what we just talked about. Well, over here, if you add 1 to both sides, you get 6. Answer of 6 right there. If you add 1 to both of these, you get negative 4. Answer right there. Now, how did I know that that was going to work? Well, two reasons. Think about this. Number one, in order to solve both of these equations, I had to add 1 to both sides. Positive 1. Had to add 1 to both sides. Number two, I knew that it was going to be 5 units to the right and 5 units to the left. Well, if I set it equal to a positive value, that was going to force two things to happen. It to be equal to the positive version, 5, and it to be equal to the negative version of negative 5. So knowing the distance between those two things told me what it was going to be equal to, because that was going to guarantee that it was going to split into both of those things. And secondly, this value of 1 right here in the middle, if I set it equal to the opposite of that, I'll have to add both of those to happen. We'll do it again. I think you'll get the hang of it. Where's the middle of that? Between a negative 2 and a positive 6. The middle's at what? At positive 2. So there's the middle right there. How many units to the right and how many units to the left? 4. So that means over here, it's 4 units to the right, and there it's 4 units to the left. That tells me right now that those two things are out, because it has to be equal to the positive version of that so that I can do plus 4 and then minus 4, like thinking about these two options over here on the left. Now, if this middle is a positive 2, if you were actually going to solve that, you would do what with that positive 2? You would. If I was going to solve that, think about over here. If I was actually going to move that, I would do the opposite of it. So the one that would work would be that one right there. You do the opposite every time. Well, because if you solve an equation, remember, everything you do in an equation is backwards. So in order to make that happen, you have to do the opposite. Now, you're going to try this with just a couple things. It's not going to take you long at all. This is in your book, so either you're going to have to use your Chromebook to open your digital book, or if you have, if you signed out a hard copy, you could use that, obviously. The first column is on the left-hand side. Columns go up and down in your book. All right? So you're going to see problems like, it's going to go 13, 14, 15, 16, 17, 18. The first column is going to be those things over there. The very end will go 27, 20, or excuse me, it'll go 28, 29, and 30. But you're only worried about the first column. So that's just going to be the things over there on the left-hand side. Yes, you can come in during advisory today.